So for this problem, we want to begin by gathering our basic statistics. We need the sample average and the sample standard deviation. The sample average is x bar is 29.4. You can either compute this by hand or, of course, using technology. The sample standard deviation is 6.753. All right, so that's where we start. So I want to form my hypotheses. We'll kind of do this in order. So my null hypothesis here is that the mean of untrained testers is less than or equal to 25, and we are sort of interested in, is this mean actually above 25? So if you stop and think about the problem, which hopefully you've done, right? We know what the threshold for wine tasters who are trained is. It's at 25 micrograms. You can put no more than that in and they'll pick it up. And so we're asking, is there evidence that the mean threshold for untrained testers is higher, that they're going to be less sensitive, which means we can put more of this sulfur in the wine and they won't taste it. So that question dictates this direction in the hypothesis here. Mu is greater than. I didn't write it down, but my mu is the average of untrained, the average threshold of untrained testers. So once you've got your hypotheses, then you can compute the test statistics. So here, t is going to be x bar, which is 29.4, minus my null hypothesis value, the value that's showing up here. I mean, it's always the same number. And then I'm going to divide by the standard deviation, 6.753, and that's over the square root of the sample size, which you can check is just 10. N is 10. When you put this in a calculator, you should get out 2.06. And so now you're on to step 3. You can compute the probability that the t-distribution with, of course, 9 degrees of freedom. Which way do I go? I go with the alternative hypothesis direction. There's a greater than there, so I'm going to put a greater than here. I write down my statistic of 2.06. I load up the app. I'll let you do that. And when you do that, you should get out a p-value of 0.03474. So my conclusion here is that the data is statistically significant and gives evidence. Here, let me erase that. It gives evidence, right, that the alternative is true. So that mu really is greater than 25.